Here we are going to see one problems. Construct the PDA for L is equal to A power n, B power n such that n greater than or equal to 1. Okay, so this is a structure of PDA. Input buffer we are having already. Then we know read write controls. It starts from initial state, and using the state we are going to move from one state to another, and we are going to read the input from input buffer, and using the stack we are going to process. Okay, here stack consists of actually the operation of stack is lost in first out, yes, LIFO concept. And we are going to do the two operations, push and pop. Generally in PDA we are going to use these operations. Push, we are going to push the element into the stack, and pop from the stack we can move the element from input buffers, and finally we can say accept the string. If it is not, we can say reject the string, and finally we can make it the stack empty also. So these are all the operations generally we are doing the push down automata. Here this is main concepts of how we are going to do the operations using push down automata. First one is, for example, this is a string L is equal to A power n, B power n. Here, first step, we are going to push one A into the stack for every A in the input. For example, we are having A power n, B power means, suppose n is equal to 3 means 3A we are having. So up to 3A, we are going to push the element into the stack. Okay. So now in stack consists of 3 A's. Now we are going to see this B means if how many B's you are going to see, this that B is going to replace by A. For example, for every B read, pop one A from the stack. For example, here 3A, A is there. So after seeing first A, the first A is replaced, first A is popped from the stack. Second B, if you are seeing second B, the second A is popped from the stack. If you are reading the third B, third A, that is this A, that is a third A is popped from the stack. Finally, the stack is empty. Again, you are going to check the input buffer is empty and the stack is empty. We can say the string is accepted by the push down automata. So the same concept here, push one A onto the stack for every A in the input. And second step, for every B read, pop one A from the stack. That's all. Here, number of A's we are going to push into the stack. If you are seeing the number of B, we are going to pop the A element from the stack. So finally, the stack is empty. So this is a concept. Generally, we are going to use this push run automata for equal number of processes. For example, equal number of A's, here equal number of B's. Suppose you are going to check the balanced parenthesis. Yeah. So we are having the expressions. We are having the expressions balanced parenthesis. Yeah. We are going to push, for example, yes. First you are going to push the stack double A, and if you are reading the A, simply move the state. If you are reading close parenthesis, first close parenthesis E, you just remove from the stack. If you are seeing the second close parenthesis, you remove from the stack. Finally, the stack is empty. So like that. So this is a way of operations doing for constructing the PDA. So next we'll see the example. L is equal to A power n and B power n. Okay. Yeah. So initially n is equal to 3, you can assume. So A is equal to 3, then B is equal to 3, then 3A followed by 3B. This is the input string initially Q0. Okay. Stack also initial symbol is Z. Yeah. Here first step, you have to see the A. If you are seeing A, how to push the element into the stack. Yeah. So next step, yes. Second strings, you have to push the element into the stack. Third string, you have to push here. Okay. So here, one step is here. If you are seeing the different character, you can change the state also. So then only we will reach from starting state to another state, that is the ending state. Okay, so now if you are seeing Q1B, here you have to pop one element from the stack. So next you are seeing the same B, you have to pop the second A. Next you are seeing the third B, you have to pop the third A. Yeah. Okay. Finally, we are reaching the empty state. Okay. So now the state is called Q2. And we have to write the rule how we are doing the process. So this is a general rule. It will be applicable for a power 10, b power 10 also, a power 11, b power 11 also. So n may be 100, a power n and sorry, a power 100 as well as b power 100 also applicable for the same rule. Okay. So first you are reading this Q naught, starting from the Q naught. The input is A means you have to push the element into the stack. So the input is A and stack element is initially Z naught means you have to push the element into the stack. Still the states are same. Again, the suppose you are pushing this element A, here the top of the element is A. Suppose here Q naught, here A, here A, here A means again you have to push the element into the stack. Still the same. Okay. And whenever we are reading the B, that is the next character, you have to write the rule. The state may be changed. Okay. As it is Q naught B, here A means you can pop the element from the stack. Again, if it is matches Q1 B A, because we are changing the characters, changing the state here. Again, you have to check if it is B, here stack contains A, you have to pop from the stack. Then finally, if you are reaching the empty state and stack is empty, that is a final Z naught, you can make it as Q2 state, you can change the state also. Otherwise Q1 also no problem, but better we need to change the state. So Q2 and make it as a empty. Okay. So this is we need to write the rule as per the problems given to you. Okay. And yeah. So this is way of checking the extended transitions. For example, this is a rule 1, 2, 3, 4, 5. 5 rules as framed as per the problem given. Here you are going to check 3 A's, 3 B's. Okay. Q naught A Z naught as per rule 1. What will happen? You have to push the element into the stack. So that's why Q naught A Z naught. This A is pushed into the stack as per rule 1. And you have to check Q naught A. A means A means against you have to push the element to the stack rule 2. Then Q naught A again you have to push the element into the stack. Okay, so now we check Q naught B A. Q naught B A. You have to change all the state Q1 and BB, then remaining states. Now you have to ensure Q1 B A, you make it as Q1 B empty, you can make it as a stack is empty, A is at naught. Then you can check Q1B A, again make it as empty, so Q1 epsilon is at naught. Okay, so as per rule 5 it will reach the final state. So now the stack also empty and we can say the string is accepted. So this is final transition diagram for this as per the rule. If starting state, if you are reading A input string, if you are the stack symbol is Z naught, we can push the element into the stack. So this is input, this is output. If you are reading A, input is A, and stack symbol also A means again you have to push. If you are reading the different characters, that means B, and stack symbol also A, it will goes to Q0 to Qn, and the stack is empty. Okay. And if you are reading again the still Q1 BA, so still in Q1 only. If you are reading the string, that is a M string, stack is Z0, you make it everything is empty and it goes to the new state. Okay. So this is a way of solving the problems. Thank you.